Before we start the calibration, it's worth explaining a few things so you've got an understanding of what we're about to do. There are two parameters on the camera that we need to calibrate. Firstly, it's the scales. This parameter uses a microns per pixel ratio, and we essentially calibrate the pixels of the camera to the scales on the machine, and this gives us accurate linear measurements. Secondly, we need to calibrate the Z rotation. So if there's a slight Z rotation on the camera to the quill or machine, as the camera tracks around a stationary component, you can get an error that builds up as it rotates around. So the Z rotation will calibrate any rotation on the camera itself. So when we are ready to actually calibrate the camera, the first thing we need to do is go to the Vision tab, and it's this icon here, Setup. It's like a little lens with light beaming through it and a little gear. If you hover over it, it says Setup. And as standard, there will be nothing in here. So the idea is every time we adjust the camera, we need to create a new ID. You can either use the same ID and recalibrate the camera after every mechanical adjustment, or you can try to create fixed IDs for each different adjustment. I would recommend using a single ID and recalibrating the camera after any mechanical adjustments. This gives it the highest accuracy without any issues. To get access to this lens setup menu, we need to put the tech code in at the top entry bar. Again, the tech code is the same as in previous exercises, 2.718. And you'll see now we have gotten into the calibration parameters for the lens setup. Now, to actually calibrate the camera, we need to create an ID. So to do this, we right click into this bar on the left hand side of the window. So right click and we say add new zoom position. This creates ID 1, and this is what we are going to use to calibrate the camera. Now, before we can actually take any measurements and do the calibration, we need to double click on this ID. So it goes green. You'll see all the entry fields now go active. They aren't grayed out anymore. And we can now look at calibrating the camera. Let's now calibrate the scales. This is done via the microns per pixel entry box, and we can access the setup via the lens setup window and the calibrate scales icon. Millimeters per pixel, that is the icon here. So if you hover over it, calibrate scales. Now firstly, I'm just going to move this over to the right and maximize this window a little bit so you can see a little bit better. And if we click on the icon to calibrate the scales, the first thing it's going to ask us is, are we going to calibrate the scales from a grid or calibrate the scales from a circle? So I always find it easier and a quicker setup to do from a circle. We'll use this 8mm circle here. So we will select circle. So choose a circle of a known diameter and enter its size above. So we've already got it in there, but if it was blank, you would just put 8.0. An ideal circle would take up as much of the screen as possible. Ensure the edges are in focus. So we will use the joystick to drive so that the 8mm circle sits in the middle of the window. And if the camera isn't already in focus, you can use autofocus just to try and get the edge as good as possible. There we go, so that's complete. And we can now click on the blue next arrow. Measure the chosen circle. The software has automatically switched to edge detection and circle mode. So all we need to do is 3 left clicks on the edge of the circle, evenly spread out. 1, 2, and 3. After you've done your final click, we just slowly move the mouse in or out. Not dragging or left clicking here, just slowly moving the mouse in or out from that window, and this sets a scanning window to look for the edge. We don't want it to be too big because this will include a lot of other things on the screen or within the scanning window, and we don't want it to be too small because the software will struggle to fit the edge within the window. So something like this will be great. So when you're ready, you do a final fourth left click and you'll see calibration finished. We get a root mean squared error or RMS error and a max error. I wouldn't expect these errors to be higher than around 10 microns. If they are, it's likely that the graticule has been damaged, there's scratches on it, fingerprint marks, or the lens on the camera is dirty, various possible issues like this. As it happens, we're happy with this. I expect it to be within about 5 microns. We click next, and the lens is now set up for scale calibration. So it has a microns per pixel ratio in here. It doesn't really matter what that ratio is, we just know that now any linear measurements we take will be accurate. We now need to calibrate the camera rotation. So now we can calibrate the camera rotation. This again is done in lens setup, and it is the icon to the right of the calibrate scales icon. This one here, calibrate Z rotation from circle. What we are going to do is use the 1mm circle in 4 different sections of the camera image. Measure it 4 times and it will write a value to this camera rotation entry, and that will be the camera rotation calibrated. So if we click on the icon to start with, you'll see it says choose a circle that will fit in a quadrant of the image and position it in any one of the corners. So when it says quadrant, it basically means splitting the camera field of view into 4 sections, like a cross. This would be 1, 2, 3, and 4. So again, we'll use the joystick, and it's this 1mm that we want. So we just use this. If you can't see anything on the screen, just toggle the camera here. This is just letting us see a live image. So again, imagine this is a cross. I'm in the first corner here with the 1mm circle. So then we click next. Measure the chosen circle in any one of the 4 corners. And the reason why I like using the 1mm circle is we double click and that gets the measurement automatically. This works for any solid feature circles. So we double click. The camera automatically moves to the next quadrant. Double click. It moves down. Double click. And then again moves to the final 4th quadrant. Double click. And this will calibrate the Z rotation, so you get a similar feedback entry as with the scales calibration. We get an RMS error and a max error. Again, I don't want these to be higher than about 10 microns. We normally get them from about 5 microns or less. So we are happy with this. We press the blue next arrow and it writes that value to camera rotation, and we now have fully calibrated the camera. However, I would recommend running some calibration tests, which is part of the next exercise, just to verify that the camera is actually indeed measuring correctly and the Z rotation isn't causing any problems. This will be really important on bigger components where the camera has to move around quite a bit to measure them. So the camera calibration is now complete, and for all intents and purposes we can actually start measuring accurately now, but it's always good for peace of mind to verify your calibration on the graticule with some test programs. The first program will verify the scales. We essentially measure a bunch of the circles on the graticule, verify the diameter and roundness is good. The second program, we use a fixed circle. We move the camera around, measuring the same circle 4 times, and we do a true position check to make sure that the camera rotation is staying fixed, the same as the part on the bed. So we can hit the green tick on lens setup now. We are done in there, and we can look to start running some tests. When the camera is calibrated, as it is now, we don't need to use the joystick to move the camera around on the screen anymore. We can use the mouse wheel. We press the mouse wheel in. This has to be somewhere on the image, so we press the mouse wheel in. We then drag the mouse over to where we want the target position to go to, and you see the camera moves automatically. This means we no longer need to use the joystick, which is a great help when trying to get some measurements done. And now we can start with the scale verification program. So just in case it hasn't already reverted to it, make sure your inspection method is set to edge detection and make sure that the feature is set to circle. We'll now measure similar to the way that we calibrated. 3 points on the edge, 1, 2, 3. We set a scanning window, and then the fourth click will measure the feature. We'll set this as a reference. We're then going to move our way down. So 1, 2, and 3. Scanning window, and 4. Hit the green tick, and then if we want to complete the reference system, which again is 2D, so there's no plane requirements as there is with the touch probe, we'll create a line between the two and set this as a reference. That's the program complete, but we need to get a few more measurements just to verify the scales are good over a range of different lengths. So we measure the 4mm, we measure the 2mm, and we measure the 1mm. There we go. And if we look at that data in the standard software, in this case the XY view, we can pull off some dimensions to verify that the measurements are good. Again, these should all be within sort of 10 microns of the nominal sizes. These are even better than that, so we know that the camera scale calibration has been verified and it is good. You can save this as a program and run it again. Often I just do it manually each time just to verify the setup. Now we need to calibrate or verify the Z calibration. So we used the 1mm to calibrate it, so it's generally a good idea not to use that, just so we're not cheating the system a little bit. So we'll just use this circle over here. So again, we're going to run the same tests as we did in the calibration procedure, only this time we will use a different circle and we actually measure them rather than calibrate them. So we measure this one, we set it as a reference. We then step the camera over to the right. We measure it again. This one is just a green tick. We step it down to the bottom. Measure it again. Hit the green tick. And then we step it over here. Measure it again. And hit the green tick. Now the idea is we will have 4 circles, so we left click, choose circle 1, left click, choose circle 1. Now we're going to right click and choose position Cartesian, and obviously this will be 0, 0, 0 as this is the reference. This is a 2D system, so we don't need the Z. And we're going to repeat that process now for the remaining 3 circles. So unit 2, right click, position Cartesian, left click to drop it down on the screen, and then if we right click on it we can remove the Z as we don't need it. Same again, left click, unit 3, left click, unit 3, right click for options, left click on position Cartesian, and we drop this down here with a left click, and to modify the dimension we right click and untick the Z, and then we repeat the same process again for the 4th circle. Right click and untick the Z. And what we're looking for basically, is for the true position to be less than 10 microns and any given axis position to be less than sort of 5 microns. As you can see, this is the case on the screen here. So we have verified that the Z rotation is all good. And we can now actually start measuring with the camera. Now finally, as a final note, it's worth noting that if you don't mechanically adjust the camera, you can now switch between the probe and the camera, and you don't need to run these calibration checks every single time. So once it's done once, it should be good for a long time to come. But there's no harm in running these calibration verification programs on your Graticule just for peace of mind should you have any issues. And obviously if they do fail, you can just go through the calibration process again. It takes 1 minute or something like this to run the calibration. So you have that option available if you doubt the accuracy of the camera or you haven't used it for a long time. That completes the camera calibration exercise. Please check the next video for basic measurement and then advanced measurement.